Alright, hey everyone, what's up? Welcome to part 2 of what I'm hoping to be this Mistborn game devlog again. So let's just get into it. Today I want to go over animation development and integration, at least for what I've developed so far, and kind of my plans for what I intend to do later in the game. And of course everything I want to be cohesive in a game sense, and so a lot of this is under revision as I get a better idea of what I actually want this to be. But like I said, let me turn this music down a little. Like I said in the first devlog, was originally I had done my own locomotion, running animation and walking animation, and it was just really difficult to make it look natural. I think I can actually show these to you. So if we go over here to Blender, let's see, is it in this one? I'm not sure if it's in this file or if it's in a different one. It looks like it's in a different file, so let me save this one second, and then we can open and go to Run, Walk, Idle. Here we go. So there was a lot of work. This was basically my introduction into animation, and I think this was my first run. It still looks pretty clunky. Does not look very good. But yeah, this was essentially what I assumed to be, at least, my first pass at a run. And this was all done in Blender with this plugin that lets you import the Unreal Engine 4 mannequin skeleton, which happens to work in Unreal Engine 5. It looks like there's no other run animation, so maybe this was actually the final run animation. I don't know, but we have an idle here. Oh, well, actually, no, we don't. We have a walk animation, which is a little better, but it's still a little bit robotic. It just doesn't have that nice variation that the subtle nuance of you know, like gravitational influence that that makes motion look so natural. This looks very stiff and robotic, which you know, it's great that I managed to actually make this and bring it out all on my own, essentially. No reference, very much at least. But I was still able to recognize that it just didn't look good, at least not to the standards that I held myself up to. So, you know, like, look, I went through all the details of even lifting the toe as you walk, and it still just does not look good. You know, you play it back, like maybe in slow motion, you're like, yeah, that's kind of how you walk. Like if you zoom in on the feet, it's like, yes, the foot stamps down and the other one comes up next to it, and then that one stamps down and the next one comes up, but then you play it, and it's just like, something's off. I suppose it's the uncanny valley. Let's see, do we have, no, don't save. Yeah, we have run 2, here we go. So this is the later run I assume I developed. Which, oh, that's right, this one I think I did develop in slower motion, and then I sped it up within Unreal Engine itself, which had a host of its own problems. I'm pretty sure I had issues where the elbows looked like they were snapping, even though in slow motion they weren't. So I don't recommend doing that. I recommend making your animations run in the real time that they're actually meant to be played at. But all of that is to say that getting basic animations like running and sprinting down is very difficult, and I think it's much better to just implement, you know, if it ain't broke, don't fix it. Implement this advanced locomotion system, which is probably the most popular plugin for Unreal Engine, and it's free. You know, I don't think they even charge you anything to put it in an actual game that you develop, and it's great. So I want to move on to jumping now, which here's a bit of a spoiler here. So I made the jump animation, the actual jump animation loop, and then I've also created this vaulting animation, which I stole directly from Fortnite. I think I just looked up a Fortnite parkour video, and I didn't even do the like Blender use a video pane as background and copy it one for one. I just did it from eyeing it, because I also made some alterations to get it. You know, if you look at the legs, they match the jumping animation. But I'll show you how I did that real fast. So if we go back into Blender, is that in this file? It is not. So that is probably in jump coin idle here. Here we go, jump. So this is the jumping animation that I made. Ooh, that looks a bit rough. Bam. And I believe I actually copied this one from the what's it called? The Unreal Engine 5 default jump animation. I just went for it. I was like, this looks good, I'm just gonna take it. And so I did. I don't know if the left hand does this weird track down motion in game. That looks a little off. I guess it kinda does. Alright, it's a little faster, it looks like, in action. And then, so we also have this jump loop, which I moved the arms up because the idea is, you know, as you're falling more and more, I wanted to have the actual jump, like, you know, if you're falling more and more, but you're still close to the ground, you're going to put your arms up as kind of the air resistance raises your arms up. Excuse me, I'm burping now. Land. This is an animation I don't think I ever used. Maybe I did, and maybe, but I'm pretty sure I'm just using the default. Yeah, the default land animation. Like that looks different than bonk. Maybe this is it. We can actually check the graph. Music's popping off. Just down a tiny bit more. So, oh gosh, yeah, if we go into the animation graph here, Blueprint Mistborn animation graph, it was honestly quite a lot of tinkering to get everything right, implemented with ALS, the animation locomotion system. It was kind of tricky, but it looks like we have a blend space here of, oh whoa, I did not mean to do that. It looks like we have a blend space here of idling. I think this is an idle I created. It looks like it, at least. Yeah, the back is too far back. It must be mine. Into a half. Yeah, oh yeah, this is definitely my janky run and then sprint animation, which you know, it looks okay, but I don't think I'm using this anymore. I'd recommend just downloading the advanced locomotion system and then learning how it works and creating your own stuff on top of it. It's definitely a lot nicer that way, I found. So let's close out of that. This is definitely not what I'm looking for. Here we go. This looks more like it. So we have our jump animation here, which if we play is the one that I showed you before, and that plays and it links into our fall loop animation, which really annoying if I am in the air or near the ground modifier. There was a lot of coding going on within the actual animation blueprint to get this right, and I'll show you exactly what I'm talking about here. But I've also created, because if you know anything about the Mistborn, is they do a lot of flying around because they influence the metals, and more importantly, they influence the pushing and pulling on it, well, move them. And so I wanted to create a smooth jumping into gliding. I didn't want this like in GTA when you enter a ragdoll state when you fall too far. I didn't want that to happen. What I wanted is you would kind of, you know, move into this falling farther and faster into Okay, now I'm full on gliding. And this is a sliding scale between 0 and 100. And this is all determined by velocity, but there's a second variable where if you're near the ground, I also don't want to be in the glide animation. I want you to be more like this because you're ready to land, if that makes sense. And that's a lot. That was a lot of figuring out in the actual code. But if we go into the game here and I just go ahead and jump off this, so here's our normal jump animation, right? We have our vault here, and then we have the arms kind of go up, and then you land fine, and that's all nice and dandy. And then if we actually jump off of this, we'll go into our glide animation, and then we orient back upwards to land. And the reason why I did that again is because these Mistborn, they kind of own the skies in the story, so I didn't want it to look like you were falling by any means. I wanted it to look like you had complete control over yourself and your body. And you know, as this is all implemented, it looks pretty seamless. There's some things I would like to improve, especially the landing from high up if you're not going to account for the speed at which you're going. That is another thing I'd like to add, but it works for this sort of proof of concept I was going for. So another thing I wanted to do was, as you were flying, because that was going to be a big part of the what is it called? The game. Oh my gosh, I don't know why I blank so hard. I also wanted to show that in the physics. So the actual glide animation, which you can see here, is just, it's this kind of idle loop where you're just kind of floating. And then we have this one frame animation here. I have another animation graph that's an additive animation graph that I'll show you in a moment. But whenever you have additive animations, you typically want to have them be about one frame. You can actually animate them and have them be longer, but your base animation is showing you how much you show the deformations, but you need a base animation to show what you're deforming from, if that makes sense. So this is the base animation on the additive animation graph. And then if we go through each of these directional leans, so here's a back lean, right? The spine is slightly raised, the legs are slightly raised, the hands are lowered a little bit. Here's a forward lean, spine is down, legs are up, arms are up. There's a left lean where the spine is curved. I think the head is slightly curved as well. And then we have a right lean, which I don't see where the right lean is, but that's okay for now, because it is in this animation graph here, glide lean. So here's our base animation, and the thing is that this animation is playing on top of the glide animation. If you see this animation is only playing for one frame. This is the base animation. So what it's saying is make no changes to the glide animation, right? And then if we do the forward lean, it says make the changes from the base to the forward lean, make those same bone position changes, but apply it to the glide animation. So if you notice, we still have the idle here, where it looks like you're kind of flying, you're kind of moving around, but none of this is actually animated in the additive animations. It's just playing on top of the original animation. So we actually have this graph for left, right, up, down. And the position of this pointer that I'm moving around here is determined by A, the velocity of the player, and B, I believe it's the velocity and the acceleration. Both are calculated. And so what it does is it takes the acceleration value, it stores the velocity value of the previous tick and then the current tick, and then it uses both of them to get essentially a slope, to get an acceleration. And it determines if you're moving relative to your current velocity, if you're actually going in an upwards direction. So if you're moving that way, you know, because you're moving this way, but before you were moving this way, it's showing you're slowly moving up. What you're going to get for the slope is this, and so that's going to correlate to this lean up, and this will correlate to lean down. It was a lot of tinkering around and messing with it, and I can show you the code for it, but honestly it was so complicated, and it was so long ago that I did it that I don't fully remember how I did all of it, especially since this is all incorporated within the yeah, it looks like this, I believe most of this is default ALS components, but this is where I changed things. Right here is, you know, we have previous velocity, so we set the last, or the last velocity to previous velocity every tick, and then we update velocity to the movement component's new velocity, and then that's also set to speed, which is the vector length of the velocity, and then I subtract the two to get acceleration. And we also do a that's right, we also do a rotation calculation, which you know, we do some math here, and I don't remember exactly why, but I believe they all come down to giving us these two values here, which is left, right, and up, down. And these are two different sliding scales that tell us, are we going left and right? Are we going up and down? So the idea behind that is, if we go back to glide lean, it's we're going up and we're going left. And so we can actually blend between those two here, where this is up and left, and this is up and right. And I was very satisfied with how this turned out. It reminds me a lot of Invincible, which just like that picture of the cover of Invincible with Invincible flying, that was kind of the inspiration for this. And that's kind of what I wanted, just this casual, like, this is so natural to him, he's just kind of gliding. And so all of that works pretty well within the game. It's kind of hard to see the actual leaning. Like if I pull here, you could see it a little bit there, but there's some things I want to iron out, because if you notice, he kind of just turns around, right? I would like it more if he did a lot more of the back lean, but just the way that it's all set to work, like if you're falling downwards, you want your head to slowly move downwards. All of that combined is kind of difficult to do. Oh my gosh. Okay, we got it. It's kind of difficult to get it all seamless without, I don't know, making a giant pile of spaghetti code. But yeah, the jump into the glide, into the reorient into a jump state before you land, that was pretty tricky to get down. And I have all the code here. I want to show that as well. I believe that is this the function? Tick in air alignment. So what we do for this is I'll turn this ray trace back on. This was a solution I had to devise myself. I don't think a lot of these I found on YouTube tutorials, especially. Let me find this channel for you, because it was very helpful in my development for this. YouTube channel, Unreal Engine 5 animation blend space. This guy, Prismatica Dev. This guy has some great tutorials if you're trying
and
to get
also
into
we
this. That was very loud. Anyway, he has some great tutorials for if you're trying to get into the basics of a game. And he did the same thing with the advanced locomotion system and kind of doing these additives on top of it and learning how to implement by that system. And that's kind of where I took that from. Originally, I was like, oh, I'll do it all myself. But man, I learned how difficult it is to get that right. At least animations, to make them not look stiff. Yeah, anyway, this was something I did not learn from him, but I do want to give him a shout out because he was very helpful, and he's much better at teaching than I am, so definitely check him out if you're having issues. But let me turn these on for a time. Turn them on for 3 seconds or so. I think it'll help you visualize what I'm trying to show you what I did. So the idea is, whenever you are moving in the air, it is casting a ray directly down. At least so long as the ground is there, it's going to as long as it's detecting ground, it's going to keep you in this jump state. It's not going to move to the glide. But the moment the ground leaves you, what it's going to do is it's going to start rotating the player capsule towards the direction of the velocity. So that way, the glide, what would happen if we activated glide right now is it would look like this character right now is planking on the ground. He just leans directly forward, at least in the within the capsule of the player collision. And so the moment that the ground leaves this ray trace right here, we rotate that capsule forward, and what we also do is we lerp this ray trace line to be in accordance with the direction of the player capsule, because of course when we're jumping it's perpendicular, it's going straight down. Let me show you what I'm talking about with the player capsule. This thing, when we are jumping, the ray trace line goes straight down from the player capsule. This is all relative to the player capsule, again, because the code doesn't know exactly what I want to do. I have to define it relative to the actual character. So the ray trace goes straight down. The moment that the ground is gone, we're going to rotate. Okay, apparently I can't rotate it. But, oh, there we go. We're going to rotate the character forward like this, right? And then when he's gliding, if he's in the gliding animation, it'll actually be like straight down, because like I said, if he's like this and he goes into glide, he'll be planking. So as he transitions into the gliding animation, we also rotate, and that will make it look like he's going straight down. And then during that tick, what we do, oh, this is tick, push, pull, tick in air alignment. What we do is this was a lot of the math that really frustrated me, because it was kind of hard to get to go correct. But we essentially want to turn the slowly. We want to move from a straight down ray trace into a ray trace that is equivalent to the velocity projection. And the reason why that we want to do that is if your character is gliding, let's say horizontally really fast, what we want to start doing, hold on, let's see if we can get him to do it. What we want to do is we want to look, admittedly, we want to look a little bit downwards, but we really want to look kind of straight where the character is headed, because if the character is headed towards a wall, we're going to want to revert him to the jump position. Oh my gosh, it wasn't the greatest example because it's still a little wonky, but yeah, essentially if you're flying horizontal towards this wall, you're going to want to, if the wall is in front of you, if it's where you're headed, then that's where you actually want to orient the jump towards, not directly below you because you're in the air. But there's also the second addition of even if you start moving slower, we're gonna slowly lerp the ray trace to be again directly below you, because the moment you're going slower on this like horizontal XY plane instead of the Z plane, we're going to assume you're going to be traveling more in the Z direction, which means the ray trace needs to be more downwards. And again, one more time, because this is something I just remembered, is that the ray trace is actually relative to the player capsule. So if you see here, as we fall, what happens is the ray trace stays almost exactly the same. It does not move. It stays down, and then even as the character rotates back into the jump position, it continues pointing this way. And that was a big challenge of this lerp implementation, because what would happen is, let's go back into here. What would happen is if we rotated the character down like this, and the ray trace is going in the direction of the capsule, so it's going straight down, and then we say, okay, there's ground here, we need to rotate him back up like this. As we would rotate it back up, if we didn't lerp the ray trace relative to the capsule at the right interval, then the ray trace you're still headed this direction, the ground is still this direction, but the ray trace would still be going in front of the capsule. And so what we had to do was lerp the ray trace to be at an angle where it was, okay, straight in front of the capsule, okay, a little bit, okay, now it's like a 45-degree angle to the capsule, and then, okay, now we're ray tracing directly below the capsule. And that's all happening live. It's kind of hard to explain, but that's all happening live in these rotations right here. If you look, the ray trace stays almost exactly a straight line, but that is all thanks to this code right here, especially, yeah, these lerps right here, and then this lerp, and this, oh, R interp 2, I don't really, oh, rotational interp, yeah, so lerp is the linear interpolation for values, and then if you actually want to interpolate the rotation of an object within the world, you have to do R interp. And that was a bit tricky because you have to take these rotation values and interp between them. You can't just give it a value. It's like its own object that you have to interp within the world object. It's quite confusing. It took a bit of learning, but yeah, I will scroll through this if this for some reason is valuable for anyone to copy. But essentially, we just do a lot of things like if you're moving greater than a certain speed, then you go this method. Otherwise, we want to just go straight down, you know, and the straight down is all calculated relative to, it looks like the capsule component of the player, where we get the rotation, and then we go +1 on the z-axis. All we want is the z rotation of this rotation object, and it's just a lot of math. Here's the line trace that's actually done, which is done in this branch. I'm actually not sure what happens if this is false. Movement vector. So if you're moving, if you're slower than, no, yeah, if you're slower than 200, it doesn't do anything. Again, it's been a while since I've worked on this. I don't know if it's actually, if 200 is a significant value of movement even, so maybe this never even triggers, I don't remember. But, yeah. So essentially, I believe this is, one of these is the interpretation. Yeah, here we go, near ground. So if it's true, we're going to want to start interping our rotation towards being straight up. And if it's false, we want to start interping towards the movement vector of our player character. So that way it actually looks like we're flying in the direction that we're flying, because you know, you wouldn't want to be just kind of straight up. But I would say in terms of just like this natural glide, it kind of just works. There's some changes I want to do where definitely as your Z movement stops, you kind of, I did want it to have this little like you know, you're cresting this arc, and so you put your arms up and then you go back down into a glide. I think that does look natural, but as you can see in the movement, it's a little finicky. And you also can just slide off. And again, this is all work in progress, something I'm picking up again through this project. But that is the in-air alignment and glide animations. Next, because I don't want this to be a terribly long video, although I think we're already getting there, is what I wanted to do, the vault animation, but it doesn't look like it's in this one. Or run 2, run, idle, combat pose, FP1. Oh, first person. Yeah, that was a different project. Jump legs. Oh, here we go. I think this is it. Jump, yeah, jump vault. Something like this. So this was all done entirely within watching, excuse me, watching a Fortnite video in the other monitor, and then kind of just putting this block here and pretending that this is what the character is vaulting over. But this was my first root motion animation, which a good thing to know when you do root motion is to start with the broad gesture, the broad movement. If you see here, I had to redo this a few times because I got this wrong, where I was moving at like all the bones in the character, and then I would move the root, and then I had to like backwards accommodate for it. What you want to do is you want to have the broad motion done first. So the root will move kind of forward as the player character moves forward, right? And then it moves up. Oh wait, actually, I think this is this is not the root. This is the root. Here we go. Is it the root? I'm missing the root somewhere here. I thought this was the root. That is clearly not the root. Oh, actually, no, this is the root. So a nice thing to know is that the moving just the root is not going to move everything else. So I believe what I did was every time I would do a big root motion like this, I would go ahead and select everything, create a keyframe, and then go for it. And that definitely helped. I have, it looks like 3 key places that I did that in. So no root movement here, no root movement here, but then here we have the halfway point, which is you kind of have it a little bit up. And what I wanted was a lot of acceleration at first, and then kind of a slower get up towards the end. Although I don't think that's actually how I settled to do it, because I just wanted it to be fun, and I liked the way that Fortnite did it, where it was just kind of loosey-goosey, ray detection. Like, if there's a climbable wall there, just press space again, and your character will just float up here, and then just instantly trigger the jump loop. And so, I believe, if you look at the beginning and the end of this animation, regardless of the spot that they're in, the actual root place that they're located in, it's the exact same pose, which I believe is taken directly from my jump loop, which was important because you want to blend between them when you're making animations. You want it to look smooth. So these are the exact same pose. These are probably actually the 2 that I started with. Was, okay, we're going to start here, we're going to end here. And I had to do this a few times, where I would move how far the player had moved, because sometimes it'd be too low and you just end up on the ground. And if you actually go into the game, what happens is whenever you do it, I kind of wanted you to go back into this fall state, where and the reason why I wanted that was because what if you vault over? Oh, I missed it. That's an issue with the ray detection, but I'll get there in a moment. But I wanted you to just kind of be able to fall into it like that. I wanted that to be an element of the gameplay consciously. But if we go into the where did I put this? This is probably, this is in here. Jump input. So here we have a lot of stuff going on. What this is doing, I'm honestly not sure what this is. Oh, this is because of ALS right here, the Advanced Locomotion System. They have their own vaulting. They have a low mantle and a high mantle. It's a lot more like GTA, and so I had to use these 2 to override it, to not have it actually switch to the new movement state or the movement action, and disable theirs so that way we could use mine. But, we got that going. The only reason, or the only instance where we actually use the default ALS movement state system is at ragdoll end. If you're ragdolling and you press space, I just wanted you to move out of the ragdoll, which it does, which is nice. But here's actually all of the code for the vaulting, which, if you'll notice, is really big. Because what you have to do first is you got to get, you know, where you are, where's in front of you, and all that. And if we go ahead and trace this line that we're doing, it should be a line, yeah, it could just kind of straight down in front of you. And if you look, it ends at about the knees, but it also goes up. It was a lot of tinkering with the values. It goes up, you know, probably a half size of this whole guy above him. And the idea behind that is you want to be able to mantle something much taller than you. But obviously not too much taller. And it was tricky getting the distance right. And I also know something that I would want to improve is not to use a line trace. I think you can use what's called an object trace, and it will just put out a giant object in front of you, like a sphere, and it will show you every point that it intersects. But I didn't know about that when I did this, so I used line trace, and so it's a bit faulty. If you notice, sometimes if you try and vault over this thing, it just doesn't detect. I think it mostly happens if you're right up against it. This line will go over the edge because this is too thin. Oh no, it looks like it still worked. Alright, that's fine. But regardless, projection from chest, right. So the next tricky part is, you know, we have this line trace where, you know, if it says, okay, it says there's actually something there, what you want to do is you want to figure out how far away from the player it is, because, you know, you could have a lot of variation in how far it is from the player. So I'm trying to, oh wait, I need to turn this on. What I do is I trace a line from the player's chest outwards into the wall to get the distance. If you see there's a horizontal line. Yeah, it looks like it's hitting it. It may be a bit finicky with these shorter these shorter, what are they called, obstacles that you might be vaulting over, but I don't remember exactly how I coded it. It looks like it's fine, which maybe that's just pure luck of not actually aligning where the player is. But the idea is you want to move the player capsule into the ideal position to where when the root motion triggers, it looks natural. And it's kind of sliding the player into position, which is a lot of, if you look at a lot of games, they do that. Like a lot of those button mash, like beat 'em up games, like Shadow of Mordor, or you know, the Batman Arkham games. I love those games, but if you look at how the attack animations work, when you hit attack, it will kind of slide the player into the position where the attack that they are giving will actually connect with the enemy. And that's what we're doing here with the vault, is when you press space, it gets the distance of the object from the chest of the player, how far away it is, and then if this fails, if this misses, we actually do a new projection from the legs. I forgot about this, so we have a fail-safe here in case the spot is too low. And then essentially what we do is you disable collision for yourself. You set your mode to flying, which I believe you're supposed to do anytime you do a root motion animation, and then you play the actual montage, and then you re-enable falling, and you re-enable what's it called, collision, and then this was all, of course, done. Oh, it's one big comment. I just started moving. This was all done within a true or false statement called vaulting, so that way you know if you can play other animations or not. Just something useful to use. But this is also, oh, that's right, I forgot about montage. Montaging is interesting because it has branching triggers. So here, originally, on completed, I would re-enable falling and collision, but that was wrong. It doesn't look right to. Let me show you why. Let me see if I can break this. and show you why this was wrong. So initially, you know, you play the montage after you line the player, and then it gives it more arc. I don't know. Maybe completed is where I wanted, but blend out definitely made more sense to re-enable collision and falling, just because, you know, you have more control over the blend out. But essentially, what these branching things are right here is you have your montage. Once it triggers, the very start, this is what it does before essentially the montage has even started playing, which is the vault montage. It gets where we want to move the player. So we have our component here, the capsule component. We have the wall normal. We have the wall location. We're doing some math with some magic numbers here. Negative Z60. I guess that's perfect to align it. We're multiplying the wall normal by 50, and I don't really know why. Again, this was something I just had to tinker with. But this is just where the determines where to place actor after chest collision. That's weird because I don't even use this value. Whatever. That's kind of strange. I believe I changed the wall normal in the leg collision so that way this piece works regardless. Otherwise, you would need a branch. I probably have some magic math here. Depending on if it's from the chest, we are probably setting the wall normal to a different value. Projection from legs, wall normal. Yeah, that's strange. This isn't used at all. I don't know what this is for. This was a big mess when I was doing it, I guess. But yeah, just what I'm trying to give you more so is just the big broad overview of you cast this ray down and then you cast a ray forward, and then that allows you to have these two normals where you can actually align where the player should be when they're doing this vault animation. And then again, it all blends back into this nice glide animation that I developed, which also still needs work, but is admittedly probably the best part of this whole project. Now, we're going to go into the final part of this video, which is the coin throwing, which is actually something I'm overhauling right now, but at least for what I've developed so far is this animation of pulling out a coin, which I don't know if you can see it in the hand right there between the fingers, throwing the coin. Excellent. We have these two animations here, which are very whatever, but you know what? They do the job, and these coins are being thrown. And so this was pretty simple to get, at least done animation-wise. If we go back to this other file in Blender, jump coin idle, coin throw 1. We have this weird pose, but that's okay because we're only going to blend the spine and the arm, essentially. Well, actually, hold on. Coin draw left. This is more important. This is how it starts. You have your base pose, and then, bam. Your hand's like this, it goes like that. And the beauty of that is if we go back into this gigantic blueprint, and then, oh gosh, here we go, coin holding blend. This took a bit of tinkering around, but we have a state machine here where we have no coin, and this is just an empty animation. Then we have coin draw, which is it's the animation I just showed you, right? Easy peasy. We play that, and then once the coin is drawn, it will automatically go into the coin hold loop, which is just a little bit of movement in the arm, and nothing else is moving, because with the ALS locomotion system, we do a layer blend per bone, and what we're doing it upon, I believe, I don't really remember how we did it. Oh yes, here we go. Is we're blending it at spine 01, which you can view by going to your character skeleton rig, I believe, and then spine 01 is this one right here. So what it does is it takes that animation and it's blending this rotation, which I believe there is a rotation in this animation if you look. Yeah, I believe it's the spine 1 up, but because we're blending from spine 1, what it's saying is leave the legs alone. Everything above the spine and connected to everything above, we're going to start animating related to it, right? So it's gonna animate the spine essentially, but it's going to leave this arm alone, and I'll show you why, because we have another blend. We have another layered blend per pose where it's all based on lower arm L, right? L, and this is blending, I believe, go back into the skeleton. This is blending the animation from, is it this? This, lower arm L. And if you look, this blend weight, because I believe this is the major thing I animated, was this piece right here, this lower arm L piece. You see it's got some nice IK rigging. But I animated it mostly from here, which is why I blended it from here. But we also have here this blend depth, where it goes 2 bones deep in both directions, and it says, okay, we're going to blend a little bit less on this neighboring bone and a little bit less on this other bone, which is why the elbow and I believe the shoulder are able to blend a little bit more. And the same thing is done with the spine here. This is cached pose for movement. So what it's blending between is this pose here, the coin holder, and the actual regular movement of the character. It's blending between those two. At least that's the base pose. And so, again, like I said in the earlier glide, is the base pose is just showing you how much you don't want to deform from the actual animation. So when the animation plays, this is the base pose, essentially. Or the base pose, more or less, is this. The guy standing like this, which is a little bit, admittedly, a little bit different than this, right? And then it says, okay, blend this, this is getting tricky, blend this pose with this pose, but do it from the spine, right? And then as it blends, it's comparing the deformations of this pose and this pose, and it's all blending based on the selected bones and the render depth. Again, it takes a lot of tinkering to get it exactly right and how you want it. And then we actually have this other weapon draw here, which is something I don't think I ever worked very much on. But essentially, we're focusing on the coin now. Yeah, the coin throwing is working. We have this new state in the blueprint, Mistborn blueprint, of activate coin mode. This sets the overlay state to coin, which is what this animation is pulling on here. This coin holder, I believe the entry weight, no coin. This is character coin drawn. Yeah, this is what adds the transition of this additive. So we set it to coin. We also set the rotation mode to aiming, which is where the camera just kind of zooms in like that and switches shoulders, which I believe is also built into ALS, which is nice. We set right shoulder from left shoulder, which I think that camera motion is done on the fly with ALS as well. I'm not 100% sure if I did my own custom version. But then we set coin mode, which is what lets us enter that animation state. Now, throw coin was a little trickier, because what we had to do was we had to take this coin in our hands, which is currently an item in the game, which is marked as hidden. What we have to do is we have to, when we enter coin mode, what happens is it becomes visible, right? And then when we throw it, we need to set it to hidden again. And then we need to get the location of the player, which is what all this is. We need to get the forward vector, which is in front of us. We need to add a certain number to the value of the direction of in front of us plus our location, which would technically be like 1 pixel in front of us, because that's how unit vectors work. We need to add a arbitrary value here, which took a little bit of tinkering again, and then spawn a coin at that location. And then what it does is it adds an impulse on the coin. We need to get the mesh component and the mesh component world location, because you need a location and a mesh for some reason to get this to work properly. But this is an arbitrary value that I've added, 20,000, which is the force, which is the forward vector of the camera rotation. So that means you can actually be looking this way. It's not necessarily the player. This is my roommate. It's not necessarily the direction of the player capsule. It's the direction of the player camera. And you can throw this coin, and as you see, I lowered that force value, I think by a factor of 10, and now it's just, the coin is just kind of wheel. But it is spawning new coins, which is cool. And the other cool thing is that these coins are child components of the metal object, so you can push on them, which means the moment that it hits a wall is the moment that you actually go flying, which is quite cool. I've also added a functionality where if you press space, or hold space more importantly, it will do the same exact process as throwing it, except it's called coin jump. It spawns the coin, but it does it below you, and it does not add an impulse. What it does is it adds this coin to this like metal selection process. It adds the coin automatically in there, and then it sets you to be pushing on it. So right now we're pushing on the coin directly below us, which lets us go up into the air, which this guy's kind of spazzing out, but you know, it works. And I think in hindsight I'm going to change this. This system is currently dynamic. As you can see, it's using the impulse kind of movement system that I have developed for this so far, where it just, it just kind of shoots you up and blends between all the animations, and you know, moves your 2-move ball so that way you move towards it, that kind of thing. And I think I'm going to change it to be a hard-coded root motion sort of thing. But you know, we'll get to that later. For now, this is the current implementation of that. And then, of course, we have deactivate coin mode, which just takes away this overlay state and the rotation mode, which I want to show you the overlay states, but I'm actually still not 100% certain where they are. Like I've said, it's been a long time since I've gone through this, and these graphs are huge. Here we go. Let's see. This is coin holder, main states. Well, whatever. I think this is a good enough rundown of that. But as for plans of what I want to do with this is, I think I'm going to switch this coin throwing thing from projectile objects. I'm gonna switch it to just a hit detect, because what I want to do is I want to gamify this. I found that this was what I was initially going to do is keep this. Let's see, throw a coin. I was going to keep this value pretty high, like 2,000, right? And I was going to let you throw the coin, and then I was going to just have you have it stick into the wall. And the moment that it stuck into a wall, I wanted to you to be able to pull yourself towards it or push your way away from it, if that makes sense. But I think I'm going to change it to just a pure hit detect. And what I'll do is I'll have 2 different branching animation paths where if there's no wall in front of you, if there's no hit detect for a certain amount of range, it'll just do this normal coin throw, right? The coin will just throw and it won't be powerful enough to actually stick at anything. And more like if you threw it into the sky, right? It's just like the player threw it into the sky, there's nothing actually there, you missed your shot, right? But, for instance, if we turn on the reticle and we see that we're actually aiming for the wall, what I want to do is I want to have this new animation that I've been working on this morning where we do a coin throw hold, where it's kind of this holding animation where the coin is shot out of our hand and our hand is then raised to the wall. And what I want to add is a tracking for the arm so that the arm is always tracking where the coin is, right? Maybe not that, I'm not sure. But then the idea is the moment that you have that, until you put the coin mode away, which is letting go of right click, you have a choice of pressing space with either forward or backwards movement, and what that's going to do is it's either going to pull you towards the coin, which will have its own arm animation, or it'll push you away from the coin, and hopefully propel you in the air, which I think will look quite nice. I just need to figure out the specifics of it, but that's the plan, is to kind of work on this like personal locomotion system to make it easy for the player to get around, make it intuitive to where it's like, oh, I throw the coin here, I jump, I move towards the coin, or I'm moving away from the coin when I jumped, so I move away from the coin. But that's the game plan for the moment, at least. It's what I'm going to try and work on. And that's most of what I've been doing in terms of animation. It's been a lot of learning. But yeah, thank you for watching. I hope some of this was informative. I don't know, it was just a lot of me rambling, but it is a good rundown of what I went through in order to get the animation states within this to where they are now. I think what I'm most proud of is this vault, because I'm really quite pleased with how it plays, how it actually feels to use. It does feel a lot like Fortnite, which I don't know if you've played Fortnite, but the vaulting is quite nice. And the gliding is cool. I think the orientation and the rotation is nice. I'm running into an issue with the hitboxes, to where the capsule is still taller than the actual player, so that is an issue I'm going to have to work on soon. And I don't love the way that rotation is working now, this kind of big arcing movement, but again, it's all work in progress. It's all a learning experience. So yeah, thank you for watching. Let me know what you thought if you watched this video, and yeah, hopefully I'll have some updates for you soon. I think I'm going to start trickling my work back into this project just for the sake of, even if it's just for resume purposes. I think it's a good thing to show off, because it's work I've expended, obviously. It's energy I've put into this, so yeah, I think it'll be good for showing off. But yeah, thanks for watching, and yeah, talk to you all later.